rotation like this. I got this. So whenever, I believe this one's a parabola right here. So whenever you have these things rotated like this, what it does is it makes where all of your cross sections are circles, but they're different size circles. So we're going to have to do this differently than this. You know, this is not a base with circles built on that cross section because all of our circles are a little bit different. This is going to be calculated in a different way. But everything I've got here, all of these are circles, right? So like if I cut this in any place, I would just have circles because when you spin something around an axis, you're going to get a bunch of circles, right? So the volume for these depends on the formula for a circle. So in a way, I think these are maybe a little bit easier than the cross-section problems because you are always using the volume of a circle for this. You can do this around the horizontal axis or around a vertical axis. If it is around a horizontal axis, everything is going to be in terms of x. And you are going to integrate pi radius squared, right? The pi is pulled out on the outside of the integral just because it is a coefficient, but you could put the pi on the inside, and you would have pi radius squared. If it is in terms of y, if you're rotating it around a vertical axis, it is going to be pi times the radius in terms of y squared with dy for that, and the limits will come from the y-axis. So let's look at an example. So we've got find the volume of the solid formed by revolving the region bounded by the graph of the square root of sine x and the x-axis from 0 to pi about the x-axis. So what's happening here for this part is that we've got this area right here, and we're going to take that area and we're going to spin it around the x-axis. What kind of shape are you going to get? What's it going to kind of look like? It's going to be kind of a football shape, right? There, whenever you do that. So what happens whenever you do that is for every little like piece that you have, every little cross section you have, it's made a circle, and that radius of the circle is that vertical line. So what we've been doing, where we've been calling something S, that S, whenever you're doing a volume of revolution, is going to be your radius, because this point gets spun all the way around. So from the axis that you're spinning around to the outside is just going to be your radius. So this, I'm going to call it capital R of X right here. So in this case, that capital R of X, the way that you find it is very much the same way as we found S, right? So it is whatever function the top of that hits, which in this case is the square root of sine X. Minus the bottom of that line, which is 0, and pretty much everything we're going to do today is going to be a 0 because we're only going to rotate around the x-axis, so you won't see any numbers other than 0 for that second part, but coming up we will do somewhere we have a different value right there. So that radius ends up just being the square root of sine x. So we're going to put that into the equation for the area of a circle, which is pi times the radius, which is square root of sine x, squared. And then we want to integrate that. just like with our cross-section problems, if it is a dx problem, you need to look at the x-axis. I definitely go from 0 to what? Pi. There. And this pi right here, in the formula on the first slide, I had it on the outside. You can put it on the inside or the outside. Sometimes it's easy to forget it if you put it on the outside, so if you want to have it there. But this is pi, whatever that radius equation is, squared. In this case, I'm going to pull that pi out. I've got from 0 to pi. When I square the square root of sine x, I just get sine x. And to integrate sine, what is the integral of sine? Negative cosine of x. And we're evaluating that from 0 to pi. So we're going to have pi times negative cosine of pi minus negative cosine of 0. That double negative right there becomes like you're just adding. Unit circle, which we could possibly have a quiz on this week. I've warned you that we could, and it's already Wednesday and I haven't done it, and we got an FRQ quiz Friday, so I don't know. We'll see what happens with that. But for the unit circle, what is cosine of pi? Negative 1. And what is cosine of 0? 1. So that double negative right there becomes positive. You're going to get 2 pi for your answer. Something like this, very likely they'll give it to you without a calculator because it is pretty quick to take the integral of. Okay, questions there? All right, let's try another one. All right, we are going to find the volume of the solid formed by revolving the region bounded by the graph of f of x equals x to the third plus 1, y equals 0, and x equals 2 around the x-axis. So I want to sketch a graph of this. So like if I do f of x equals x to the third plus 1, it's a cubic moved up 1. So if I plug in 0, I'll get 1. If I plug in 1, I'll get 2. If I plug in 2, I'm going to get 9, which is too big. So I'm hoping that that is going to not be necessary for that. If I plug in negative 1, I will get 0. If I plug in negative 2, I will get negative 2 to the third, be negative 8. I get like negative 7. That's too big also. So you're getting something that looks like this. And then we've got y equals 0. What is y equals 0? That is a horizontal line. It is the x-axis. You're both correct there. And x equals 2 is going to be, oh gosh, I didn't make this graph very good, did I? X equals 2 is right here. So I really didn't make that go up high enough right there. How could I figure out where it actually stops since my graph's not big enough? What? If I find f of 2, I can figure out where they cross. So if I plug in 2 right there, even though, do I really even need to know the y-coordinate there? I'm rotating around the x-axis, so I don't really even need to know the y-coordinates. Just know it does cross somewhere up there. So this is our shape that we're going to be rotating around the x-axis. So this, what is it going to look like whenever you spin it around? Yeah, I think this one looks like the red one that they did earlier, just in a different orientation. You're going to have sort of like a sombrero look to this one. So we are spinning around the x-axis, so we go from the x-axis out towards the edge of our function that we are, our region right here. This is your r of x. And if we are looking for that r of x, it is top function, which is, or where our radius hits that top function, is x to the third plus 1. And as I said, it's always going to be 0 for everything that we do today because we're going to be rotating around either the x or the y-axis. But I'm going to keep doing that because we will rotate it around some different lines, which will change that there. So top minus bottom, x to the third plus 1 minus 0. Then we want to take that and plug it into the area of the circle formula. So it's going to be pi x to the third plus 1 squared. This will be in terms of x. Integral from, oh wait, I was getting ready to do integral from 0 to something. Is it 0 in this case? It is not. It is negative 1 up to what value? 2. Yeah. Yeah, we'll pull those from the x-axis here. And for the sake of time, I'm going to type this into Desmos so that we don't have to spend an extra long time. It's not that bad to do by hand, but I will. And so if we type that in, we're getting 90.882. Whatever units we have there. Okay, questions there? It's pretty similar to what we were doing. It's just our S is now our R of X, and it's always pi R squared for these. Let's do one around the y-axis, because those are always a little bit more difficult. We've got the volume of solid formed by revolving the region bounded by the graph of y equals 2x squared, x equals 0, y equals 8, in the first quadrant around the y-axis. So if we got y equals 2x squared, if I graph it, if I plug in 0, I'll get 0. If I plug in 1, I'll get 2. If I plug in 2, I get 8. Hopefully, we don't need to go any further than that. And it tells us only the first quadrant, so I really don't need anything past that. I've got x equals 0. What line is x equals 0? That is the y-axis right here, which is where I'm rotating around. And then I've got y equals 8, which is going to be the horizontal line right here. So we are looking at this area right here. Okay, everybody okay with our region? So this time I'm rotating around the y-axis. So the radius of my circle is going to be from the y-axis out to whatever function is on the outside of that area. Okay, because this gets like spun around in a circle here, and that is your, actually, I should not put capital R of X. What should I do instead? R of Y, because it needs to be in terms of Y. So, if we're doing this in terms of Y, I've got to switch this equation right here. I've got Y equals 2x squared. I can't use that because it is solved for the Y, and it's in terms of X. So I've got to divide by 2. So Y over 2 equals x squared. and I have to square root both sides. Now, when you have a function, well, it's not, if you have a plus or minus, whatever you've got is not really, I guess it's a function in its original form, but it's not a function of y right here because you got a plus or minus. It's really like two separate equations. You've got x equals positive square root of y over 2, and x equals negative square root of y over 2. Okay? So, what happens is this one right here, the x equals square root of y over 2, where it's positive, that is this side of that function right here. This one would be over here. It'd be your negative side of that function. So we want to choose the positive part. We want to use this part because we're in the first quadrant. If they had us in the second quadrant instead, then we would use that negative there, but we're in the first quadrant. So when we're doing our R of X, or R of Y, we want to take right minus left, much like we were doing with our S. On the right side, we hit the y, square root of y over 2. So we got square root of y over 2. And then on the left side, it's just 0, which I said is going to be that way every time for the problems we're doing today. And so we're going to take our radius, we're going to plug it into pi times that radius, so square root of y over 2 squared. It's going to be in terms of y. I'm going to integrate it. What should the limits be? Very good, Emma. 0 to 8. Not 0 to 2, right? Some of you were thinking it, I know. But 0 to 8, because you got to look at that y-axis there. And this one's not terrible to do. It's nice whenever your square root and your square cancel each other out. So you've got the integral from 0 to 8 of pi times y over 2 dy. I would just take this, I would take the pi over 2 out front and not worry about it. Like that. And then you're going to integrate, so y squared, you'll have a 1/2 out front. You'll also have that pi over 2 that was already there. And you'll evaluate that from 0 to 8. So I would put the pi over 2 and the 1/2 together and get pi over 4. And then you'll have 8 squared minus 0 squared. So we got pi over 4 times 64. And 64 divided by 4 is 16. So we get 16 pi for that. Okay, questions? Similar to what we were doing, but you're always using power squared. And in this particular case, your R value, you're always going to have -0. We'll see that change, though, in the future. All right, so our textbook has several of these. So you've got 1, 3, 7, 9, 13A, 14B, 25, and 33. And let me look at them really quickly and tell you which ones I'm going to let you use the calculator on. let's see.
And this does not count fishing.
Because I was on the patio. The patio, yeah, that. Okay, I think that's why, because technically, like I could shot at Hank, but I was waiting to get the parking lot because I didn't think it counted on the patio. But you're still in, he didn't. So do sidewalks count?
All right. You can use the calculator on. Let's see. One's going to be easy. 1 and 2, 1 and 3 are 7 is pretty easy. You can use the calculator on 9. 13 is going to be pretty easy. 14. I'll let you use it on 14B, although it's not that bad. 25 and 33. So you guys can use the calculator on those that I highlighted there. Alright, so since we have lots of, we've got an AP exam coming up. We also are getting senioritis and we're not serious enough in 4th period. I need everybody to do me one question before you leave. So everybody, try to get at least one done before we go. I know it's only 10 minutes, but try at least one before you go. I'm afraid that we're getting a little